record here. All right, so today we're going to go ahead and talk about our next section, 1.1, linear equations. And also, I still don't have the pen for this board, wherever it may be. All right, so today we're going to really introduce kind of like the core concept of what algebra is. I've mentioned this before. If you've gone through any high school math before, then you've probably learned that algebra, if I were to sum it up, is let's solve for x. You have some type of equation. It might be really big and complicated, but I want you to solve for x or solve for some letter. So to start us off, before I talk about what a linear equation is, let's go ahead and discuss what is an equation. So someone tell me what makes an equation? Well, an equation. What's an equation and what's not an equation? Y'all can just yell out the answer as needed. Yeah, the whole point, it's in the name, right? Equation, equal sign. The whole point of an equation is that there is an equal sign and then something on the left of the equal sign, something to the right. So some examples of really easy equations that y'all would probably agree is an equation. So if I give you the equation, let's say 1 is equal to 1, is that an equation? Yes or no? Yeah, it's an equation, and it's true. We know, or I hope we agree that 1 is equal to 1. If I have something like this, if I have like, I don't know, an x equal to 3, is that an equation? All right, yeah, this is just saying that x is 3. What if I give you this? 3 is equal to 4. Is that an equation? Yeah, so it's still an equation. It's not a good equation. It's not correct, but it's still an equation. Because again, I just said earlier, an equation is I have an equal sign, something to the left, and something to the right. The reason I mention this is that if I give you an equation, it doesn't necessarily mean it's true. You have true equations and equations that are wrong. So clearly, if I wanted to make this right, it would be more accurate if I wrote that 3 is not equal to 4. So we know what an equation is. Now let's go ahead and talk about our linear equations. So definition. We're going to formally define what a linear equation is. So a linear equation is, well, quite obviously an equation. That can be written in the form, and we'll write this as ax plus b is equal to 0, where a and b are real numbers, and a is not 0. So let me rewrite that one symbol a little bit nicer. There we go. So this little symbol I have here, A, B, and it kind of looks like a weird looking E. This is like epsilon. Remember, we use the symbol R for real numbers. All this means that A and B are real numbers. There's some random real numbers. So this is what we have as a linear equation. It's something that I can write in this given form. Ax plus b is equal to 0. So I also want to put a key emphasis on the word can be written in this form. Every linear equation, it might not look like this from the beginning, but what matters is that I can rewrite it in some type of way. So I'm going to give you a couple of examples of what a linear equation looks like. We'll do some that are more obvious and some maybe not as obvious. So what I'm about to write on this board, just random examples, sort of like scratch work. If I give you something like this, 4x plus 1 is equal to 0. Is that a linear equation, yes or no? Yes, it looks like a number times x plus a number equal to 0. So it's a linear equation. What if I had, I don't know, 7x minus 2 equal to 0? Is that still linear? Yes. Even though there's not a plus in the middle, remember what I mentioned last time, subtraction is just adding with a negative number. So if I wanted, I could say that this is 7x plus negative 2 equal to 0. So it still matches that form. All right, how about if I wrote, let's do negative 8x is equal to 27. Is that a linear equation? Is it possible for me to rewrite this to look like what I have here? Yeah, because if I just subtract 27 from the left and the right, this is the same thing as me writing this. Those are both the same equation, essentially, and it has that same matching form, ax plus b. So what I'm trying to get at is whenever you look at an equation, it might not look linear, but if I can rewrite it in that way somehow, then it is actually linear. So we have the definition of a linear equation. I'll give y'all some time to copy this down as needed. So as you can imagine from the name of today's lecture and the definition I gave y'all, we're going to do all of today focused on how do you solve a linear equation. Again, for some of y'all, this might be a very quick review, but it also gives us a really good foundation, at least to start off with. I think I still see a couple of pencils moving. Once I get those Blackboard worksheets up, the way that's going to be formatted, it's going to look like a worksheet where it has like example 1 and then some blank space for y'all to write in as needed. One other thing I'll note while y'all are still writing is that for a lot of these examples that I'm going to give, I don't have a finished copy of the notes with me. In other words, what y'all see is the exact same thing that I have. In other words, if I look at an equation, I'm not going to automatically say, all right, the answer is 27. We're going to work through it together, per se. All right, so let's go ahead and move on to our first example for today. Example 1. Instructions, solve for x. And let's say I give you the equation. Let's start off with 20x plus 40 is equal to 70. So that's, here's our first example. So anytime I say the word solve for x, this is me saying I want x alone. I want my final answer to be x equal to whatever number. That's my end goal. All right, so we have 20x plus 40 is equal to 70. Anyone here have a guess on what's the first thing I should probably do? Go ahead and yell out the answer. Yeah, subtract 40. In particular, we're going to subtract 40 from both sides. So I'm going to go ahead and say minus 40 and minus 40. I'm going to take a pause here for a moment to reiterate a couple of things. Remember, this is an equation. The left and the right side are supposed to be the same. So whenever I subtract 40, since I want them to be the same, I need to do the same thing on the left and the right. That's why I'm not just going to write minus 40 on one side. It has to be equal. So I have to do minus 40 on the left and the right. The other thing I want to talk about is why did we particularly choose minus 40 and not plus 40 times 40 divided by 40? Yeah, so here I see I have plus 40, adding 40. To get rid of plus 40, I need to do the opposite operation, which is minus 40. So I think I mentioned it for this class before, where I'm really emphasizing we're doing the opposite operation. So opposite of plus with subtract. All right, so let's go ahead and clean this up now. 20x, I didn't do anything with that. Plus 40 minus 40, I get 0. I'm not going to bother putting plus 0. And then 70 minus 40, I get 30. So now I got 20x is equal to 30. So again, I want x alone, but right now I don't have x. I have 20 times x. So times 20 is right there. So I need to do the opposite of multiplying by 20, which is dividing by 20. So I'm going to divide by 20 on the left and the right, giving me x is equal to, someone tell me what's 30 over 20 cleaned up? 3 over 2. Again, you can think of this 30, it's the same thing as 3 times 10. Side note, and 20 is 2 times 10. So the 10s cancel out, leaving me with 3 over 2. Alternate method, if you have your nice calculator, you can type in 30 over 20. It's going to give you a decimal, but you can use your fraction feature on your calculator, and it'll pop out 3 over 2. All right, so we're done with example 1. We just solved a linear equation. We got x is equal to some number. Any questions about what we did on any of the steps here for example 1? All right, so that was example 1. We've pretty much learned the basic concepts that we'll be working with for today. So pretty much the rest of lecture, we're going to be doing a bunch of different examples with scenarios that you may encounter. This one wasn't too bad because it was just 20x plus 40 equals 70. There wasn't much going on there overall. Let's go ahead and look at example 2 now. Example 2, same instructions, solve for x. And let's say I have -3 times x plus 4 is equal to 9. Big difference I'm seeing here already is that there's parentheses. I'll give y'all a moment to write this down. So there's 2 ways that you might do this. Probably 2 intuitive ways. There's a lot of different ways you could do it, but there's probably 2 ways that people might be thinking of. So if I wanted to solve for x here, someone give me what would y'all do first? What's something that you could do? Yeah, so one thing that we could do, I'm going to show y'all 2 ways that we can do this. First way is we can distribute the -3. In other words, I can take this -3 and say -3 times x, and then -3 times +4. I'm going to call this method A. If I do that, remember, distribute just means I'm multiplying -3 to each part in my parentheses. So -3 times x, I get -3x. -3 times +4, what do I get? Correct. And then this is equal to 9. We didn't do anything on the right. All right, so by multiplying and distributing that -3, I've gone ahead and got rid of my parentheses. And now I have an equation that kind of looks like what we had before on the previous one. Now all I had to do is solve for x. Someone walk me through what would y'all do? Add 12, giving me negative 3x. Negative 12 plus 12, I get 0, equal to 9 plus 12, I get 21. Yes. Giving me x is equal to negative 7. All right, so I agree with that. We should be getting negative 7. So this is one way that we could have done it, multiplying that negative 3 out to the x and the plus 4. Does anyone have another method that might be useful? Yeah, so let me rewrite this problem. This is going to give me the exact same answer if I did it right. Let me rewrite this. Negative 3x plus 4 is equal to 9. One thing I could also do here is divide the left and the right by negative 3. Because this is negative 3 times this parentheses. So really, there's nothing stopping me from doing this here. So if I do that, negative 3 cancels with negative 3, leaving me with x plus 4 is equal to 9 divided by negative 3. I get negative 3. And now I have another equation that we know how to solve. I can just subtract 4, which gives me x is equal to negative 7, the exact same answer. So here I showed y'all 2 ways that you can deal with this problem. On the exam, one thing that I personally always hated is whenever I saw the instructions, you have to use this particular method. As long as it's legitimate math, then I'm fine with you using whatever method. One thing I don't want to see is you looking at the beginning equation and you say x is negative 7. One thing I'm probably going to write on your paper is how'd you get that? You're right, but I don't know how you got there. All right, so that's example 2. Questions or anything about how I worked through example 2? All right, so since there are no questions, let's see if y'all can do this next one by yourself or with your friend or whoever. Example 3. Let's use this here. Example 3, same instruction, solve for x. Let's do 7 times x minus 1 plus 5 is equal to 3x minus 2 times 2x minus 1. So take a moment and see, maybe compare with your neighbor, talk to each other, whatever. See if you can solve this equation. What is x equal to? And I believe your final answer is probably going to be a fraction that's relatively clean. Um, for the most part in this class, we're going to be keeping it in fraction form. If I ever want a decimal, you'll see it in this direction rounded to decimals. I'll say it very directly. So for your final answer, I would prefer if you keep it in fraction form rather than a decimal. If you're using a calculator and you got a decimal answer, remember that most calculators, they have that feature where if you have a decimal, you can convert it to a fraction. If you don't know how to do that, I can always show you after class or right now, I guess. One thing I'll warn y'all about is be careful whenever you're distributing that -2. Make sure you're distributing a -2 and not a +2 on the right side. So really the only thing we did on Monday was just a review of like how do you add, subtract, multiply fractions. Today is actually the first quote unquote real lecture. Okay. Yeah. All right. So hopefully you had some conversation with your neighbor and y'all decided on what could be a correct answer. Let's go ahead and work this out. So looking at this problem, the first thing I notice is that there's parentheses. There's two pairs of them. So for me personally, I want to go ahead and get rid of these parentheses. So let's start on the left. One thing I can do is let's distribute the +7. So I go 7 times x, 7 times a -1. So 7 times x, I get 7x. Not a big surprise. 7 times -1, I get -7. And then I have a +5 here. I didn't really do anything with that. So I got my left side. On the right side, 3x. There's no parentheses there. I'm not worried about it yet. And now I have another set of parentheses that I'm going to distribute a -2. Remember, I'm not distributing a +2. So if I distribute this -2 to both of these, what's -2 times 2x? -4x. And then -2 times -1, +2. A big mistake I always see is that people, they put down -4x, perfect, but then they put -2 because they forgot it is -2 times each one, not a +2. So just something to be careful about. All right, so using that, I got rid of my parentheses, and now I'm going to try to clean up anything that I can immediately. On the left, 7x, there's nothing I can do there. But I can definitely do -7 plus 5. What does that give me? Yeah, we got -2 minus 2, however you want to say it. On the right side, 3x minus 4x. I can definitely combine those to give me a -x. Or if you want, you can put -1x. They mean the same thing. Plus 2. So again, all I did here was combine my -7 and 5. And on the right, 3x minus 4x. All right, so now what can I do? Or someone lead me, what's the next thing I can possibly do? Yeah, so I know if I want to solve for x, usually I want to move all the x's to one side and all the plain numbers to the other. So a lot of people, they're probably going to move the x's to the left. So this is minus x, the opposite of minus x, we got plus x. And while we're at it, let's go ahead and move the numbers also. If I move the x's to the left, and if I move the numbers to the right, I want to move this -2. To move the -2, I got to do the opposite, which is +2. All right, so I did all this in one step. I moved my letters and I moved my numbers around. Let's see what happens. What's 7x plus x? Perfect. -2 plus 2, 0. -x plus x, 0. 2 plus 2, perfect. And again, I did it in this way so that one side has x's, the other side has plain numbers. And what was that? Yeah, so I want x, but there's an 8 in the way. That's a times 8, opposite of times. We got to divide. So let's divide by 8. What's my final answer then? Yes. And move this up a little bit. Go. We get x is equal to 4 or 8. I can reduce that down to 1/2. And 1/2 is already reduced all the way. We're done. All right, so we've gone ahead and solved for x. One thing that I haven't been mentioning is that how do I know if my answer is correct? How can I be 100% sure? Yeah, if I want, one good thing about algebra is that I can always check my answer. This is saying x is 1/2. So if I go all the way back to the beginning and plug in 1/2 in for x, then I'm going to see, is it true that the left side is the same thing as the right side, whatever that number might be? All right, so we're done with this example 3. Any questions about any of the steps that I worked through here? So this problem so far, yeah, not a problem. So let me zoom out a little bit. All right, so we have this original problem, right? One thing that I'm noticing is that there's a pair of parentheses. And usually I want to try to make this look as clean as possible. So that is getting rid of the parentheses. So on the left, to get rid of these parentheses, I can multiply this 7 out. 7 times x, 7x. 7 times -1, -7. And then I just bring down the +5 because I'm just carrying it over. I didn't change the 5 at all. And then I can do the same thing on the right. 3x stayed the same. And then multiplying this -2 out. -2 times +2x, I get -4x. -2 times -1, I get +2. All right, so that gives me my first line here. To get to my next line, I'm just going to combine any like terms. So here on the left, 7x, there's no other x's on the left. There's nothing for me to do there. But here, I can definitely say -7 plus 5, I get -2. You can also say 5 minus 7, I get -2. On the right, I do the exact same thing. 3x minus 4x. 3 minus 4, I get -1x plus 2. All right, so from here, my goal is to get x's on one side and the numbers on the right. So y'all decided, let's move the x's to the left. So if I want to move all the x's to the left, this x is already on the left. I don't need to do anything for that one. But this x, to move it over, I need to add an x. That's why there's plus x here, plus x over there. Well, if I move my x's to the left, I need my numbers to the right. So this number is already on the right. I don't need to touch it. But this number, this -2, to move it to the right, I need to add 2. So that's why I have +2 here and here. And then from there, I just add downwards. 7 plus 1, I get 8x. -2 plus 2, 0. -x plus x, 0. 2 plus 2, I get 4. Giving me 8x equal to 4. And to finish it off, I need to get x by itself. There's a times 8 in the way. Opposite of times 8, we got to divide by 8. Giving me 4 divided by 8, which finally cleans up to be 1/2. You can either use your calculator, you'll get 0.5, and it'll pop out to be 1/2. Or you can recognize 4 is half of 8. Either way, you would get 1/2. All right, so that was example 3. Any other questions about this before we talk about our last one, example 4? So there's one thing that I've been avoiding so far in all of these linear equations, and probably ones that you don't want to look at. What happened? Yeah, exactly, fractions. So let's go ahead and look at this next example. This is example 4. Same instructions, solve for x. So what if I have something like this? X over 5 minus 1/2 is equal to x over 6. Something like this here. So I'm going to say first off, again, there's a lot of different ways that we can tackle on this problem. Some of y'all might be saying, dang, I got to get a common denominator and clean up all this stuff. But for me personally, I do not want to look at these fractions anymore. What is one way that I can get rid of all of these fractions very quickly? So I'm going to claim that there's a certain number that I can multiply by on the left and the right. That would help me a lot. Anyone have an idea what that number I might be thinking of is? Look at the denominators, 5, 2, and 6. What number does 5, 2, and 6 all go into? So I'm hearing 30. 60 could be a good option too, but let's go with 30 because that's our lowest option. Because, well, 5 goes into 30, right? 2 goes into 30. 6 goes into 30. So instead of me getting all this common denominator like what we did last time where I did like multiply or cross multiply, let's just multiply everything by 30 and let's see what happens. I'm allowed to do this because as long as I do it to the left and the right, it's perfectly math legal. Again, I found 30 because 5, 2, and 6, they all go into 30 perfectly. You could have said 60 just by saying 5 times 2 times 6. That would have worked as well. It just means that you probably have an extra step later on. All right, so let's see what happens. On the left, I can multiply out 30, right? I can do 30 times this and 30 times that. So for the first one, what is 30 times x over 5? So 30 times x over 5, just as a reminder on how we can do this, there's going to be side work here. 30 times x over 5. One way you might think of that is that this is 30x over 5. And then what's 30 over 5? 6. Or you could have looked at this directly and said, this is basically saying what's 30 divided by 5? So we get 6x. That's from this first one. Yes. We're multiplying it. This is not 5x, it is x over 5, or like 1/5. So that's why we're not doing 150. If this was 5x, yeah, it would be 150. This is technically divided by 5. So using that idea, what's 30 times negative 1/2? Yeah, we get minus 15. Because you can do 30 over 2, or, well, 30 divided by 2. I get 15 either way. Again, writing this out, 30 times 1/2, that's 30 times 1 over 2, which is 15. So that's the left side. What about on the right? What am I going to get? Well, I got rid of all my fractions. And now I have a problem that looks a lot nicer than where I started off. This is me not doing anything about getting that common denominator. Technically, I did, but then I did it without really mentioning the word common denominator each time. So I think we would all agree that looking at this one, this is a lot better to look at than all of these fractions. So this is my big jump going from that first line to the second line. I multiplied by 30. If you did 60, it just means that all of these numbers would be doubled. It would be 12x minus 30 equal to 10x. I'm going to take a pause here. Any questions about why I chose 30, how I multiply 30, or anything like that? Yes. All right, so I'm going to move on from here. If anyone has other questions, of course, you can always ask me after. So now that I have this equation here, this is really nice because I don't have to deal with that common denominator stuff, any of that. What's the next thing I can do here? Yeah, I can go ahead if I want. I can subtract 6x because I'm at the step where I can move all the x's to one side, all the numbers to the other. So let me erase this here. If I subtract 6x from the left and the right, I get negative 15 is equal to 5 minus 6. I get negative 1x. I want to take another pause here. I know I've been saying take a pause a lot. We don't always have to have x on the left because in equation, you can just always swap it back and forth. It's okay if x is on the right side. Yes. Oh yeah, so we just have one more step. Again, my goal is a plain x. This is not a plain x. So it's negative 1 times x. I just need to divide by negative 1. Or technically here, you could say times negative 1. It doesn't really matter. Negative 15 over negative 1, I get positive 15 equals x, giving me my final answer. So this is me saying, if you want it, you could avoid the fractions from the beginning by multiplying by a particular number based off those denominators. Do you have a question? Yeah, so just to emphasize that it's okay as long as we're consistent. Some of y'all might have said, why can't I just subtract 5x and then move the 15? So let me do that real quick. Because a lot of people tend to be comfortable saying, let's put x on the left always. Subtract 5x, for example. 6x minus 5, I get x minus 15 is 0. Exactly, plus 15, I get x is equal to 15, which is the same thing. So this is me saying it doesn't matter as long as you're consistent on your left and right. You can always move your x's to the left, you can move to the right, or you can say whatever is more convenient. So this is a method that I personally prefer. If you're a person that really wants to say, all right, let's get a common denominator, multiply this by 2 over 2, and then this over 5 over 5, and then clean up from there, that's perfectly fine. I know that's typically what probably what y'all have learned before, but this is my particular method that I prefer, multiplying it by a certain number so I can get rid of all the fractions at once. Because I know that people hate fractions, I do too. I'm still going to put them on the test probably, but at least y'all can deal with them. Any questions about example 4 or anything that I talked about for today? All right. Besides that, that's all I have for y'all's lecture. Blackboard will finally get updated either today or tomorrow, where I'm going to upload all the notes for our first unit of material. And if you want, you can print out the worksheet or anything like that. That way you don't have to always try to copy down every single word for definitions. All right, y'all have a good Wednesday.